Students, Assalamu alaikum. I'm Amir Hassan, Assistant Professor, Islamic University of Science and Technology. So we'll be studying CAD for the 7th semester, BTech Civil Engineering. So this will be the lecture 1, and this lecture will be studying Introduction and the basics of CAD. So before moving on to CAD, let's have a look overview of our syllabus. So in Unit 1 we have annotation, and then in Unit 2 we have attributes, and in Unit 3 we have Stat Pro basic concepts, and then Unit 4 we have Stat Pro design. Then Unit 5 we have introduction to various other softwares like SAP, ANSYS, SAFE, STAT, Foundation, and Corel, and we'll be studying features and feasibility of usage of these softwares. So speaking of Unit 1, so in the Unit 1 we have annotation scale, overview, and annotative style. So mostly we'll be dealing with annotations only. But the funny thing is that we can't just jump start with annotation, because annotation is just one part of AutoCAD, and if we start studying annotation only, then it will be like starting from nowhere. So first of all we'll be having look what is CAD, what's AutoCAD, then we'll be starting with AutoCAD basics, and then finally we'll reach to annotation, then attributes, and then we'll be starting with third unit, Stat Pro. And Stat Pro third unit, it's pro concepts. So it's like first part is like geometry, and then geometry and analysis of this analysis in Stat Pro. Then Unit 4 we have design. So this is actually Stat Pro has been divided into 2 units. So first part is analysis part, and then second part is design part. So Unit 5th is just introduction to various other softwares, advanced softwares. So moving on to first, let us study what is CAD. Let's have this concept. What is CAD? So CAD doesn't, most of the people have this concept. CAD means AutoCAD. No, this is wrong. CAD means computer aided design or drafting. So whatever the applications or software we use for the design or for the drafting of our projects, that software application is called CAD. So why do we use CAD? So it's obvious, the reliability. Most of the results we get from the CAD, they are more reliable than our manual calculations, because the human error is mostly human error is not present in our CAD applications. Then we have speed. Of course, the projects which manually, if we do a project, or if we draft a project, then it will take almost a week or sometimes a month to design a big project. In STAT or CAD or any other software, when we use these softwares or these applications, the speed is much faster. The project we used to finish in weeks or months or days, we can finish in hours. Then economy. Obviously, if the time is reduced for this designing and drafting, the economy also increases. So our projects become much more economical, and our manpower and time is also reduced due to CAD. Then most of the CAD applications, they are user friendly. They are made user friendly, and day by day, year by year, every software is made much more user friendly. Much more add-ons are available in there, just like our annotation. So we have this first unit, annotation. This annotation has been introduced in 2008. It has been modified in annotation scaling, has been modified in 2008 version of this AutoCAD. So then in 2016 the rendering has been improved. So day by day they are becoming more and more user friendly. Then drafting softwares. So CAD, we know it's computer aided applications, drafting or design. So talking about drafting, what are the various application or softwares available for us? So let's take a few examples. We have AutoCAD, the classic legend. It's AutoCAD. Almost every civil engineer, architect, or even most of the engineering branches, everyone knows what CAD is. So everyone deals with the CAD. Most of the engineers deals with the CAD. So they design, they draft it the CAD, and we'll be studying also the CAD. Then Revit. Revit is mostly used by civil engineers and architects. So the Revit software is actually 3D software. So it's mostly used for 3D rendering and to give a most aesthetic view of projects. But also it can be used for as I said earlier, the add-ons have come for various softwares, just like CAD. Revit has been some latest softwares, some latest add-ons. They include also the designing part also in the Revit. Then we have 3ds Max. This is actually the modern day uh, rendering software. So this is a 3D software. Mostly this software is used as a 3D software. So all these three softwares are they are from Autodesk. So then we have sketches, just like Revit is also used by architects and also by civil engineers. So this is also it also manifests our drafts, our drawings or our projects in 3D. So then we have 3D, just like it's a old software, and just like AutoCAD, we can go for 2D as well as 3D drafting in this software. Architecture 4D, or it's also called a 3D 3D architecture or 3D home architecture. This is just like 3D home. So mostly not much difference in these two softwares. Then we have various other softwares by various other companies, various other most of the some of the companies, some of the multi MNCs, multinational companies, they make their own softwares for this piracy issues or security issues. So there are various softwares available in the uh, market. So mostly these softwares are used in civil engineering or any other branches. Then we have designing. While going for the designing, we have softwares are STAD. We'll be dealing with the STAD. We'll be studying the STAD in this semester. Then we have SAP. SAP is much more advanced version of SAP, and the results from the SAP are much more feasible and much more accurate than STAD. SAP is actually the uh, much more finer version of STAD. Then we have etabs. SAP and etabs, the interface is same almost. If you know how to use SAP, then you can know how to etabs. Almost these two softwares are almost the same. Then we have Strap. Strap is a frontline software. It's also a designing software. So we'll be just having an introduction to that one. Then we have RoboCAD. RoboCAD is just from this Autodesk. This one, mostly this software is used by mechanical and uh, IT engineers, but this software is also used by uh, civil engineers nowadays. This is a very useful software. Then we have GT Strudel, just like Strap. GT Strudel is also a frontline software. It's a modern day software. So then we have ANSYS. ANSYS is actually a research-based software. So it's used in memory analysis, and it can be also used for designing, but the designing will be very tedious in this software. But the results in the ANSYS are much more finer and much more accurate, because this is a finite elements or analysis software. Then we have Abacus. Abacus is just like ANSYS. This ANSYS is actually the modern version of this Abacus. Abacus is an old software, but these two softwares are um, finite element software. So if you want to go for the ANSYS or Abacus, you have to study first finite element analysis. Then there are various other softwares. I have said earlier, uh, various other companies make their own software. They hire some software guys and then tell them that they want their own software for their own projects. Then moving on to our main unit, first AutoCAD. So first of all, what is AutoCAD? AutoCAD is a 2D or 3D drafting software. So some add-ons are there for designing, but mostly they are not used. So then we have it was released in 1982. Then after 1982, in 1982, it was a basic software, the command line software. It was at that time, so graphic interface was not that much. Uh, uh, improved at that time, and the files were like DFX files. So after that, the AutoCAD has with time it has improved a lot. So then we have this AutoCAD. It's used by civil engineering branch, civil engineers, computer engineers, and mechanical, of course, computer mechanical engineers, then electrical engineers, physics engineering. This AutoCAD is also used in that one, for animation also. Then we have industrial engineering, manufacturing engineering, maths, etc. Then we'll be moving on to our AutoCAD software. We'll be studying how to use that, how to work in AutoCAD, how to work with our drawings, how to work with our projects. So in this lecture, let's see how much you can complete. So first of all, we'll be studying commands. We'll be studying in this, of course. Then first of all, we'll be learning how to set up a file, and then we'll be learning how to set up units in AutoCAD, how to set up limits, and this limits I will be telling you what are limits, how to set limits, and what are benefits of limits. Then if we get time, we'll be using lines. Obviously we'll be using lines in this lecture. Then points, what are points, then circles, ellipses, arches. So mostly you won't be able to finish this all of these lecture, all of these topics. So let's see how much we can finish and where we will reach. And arches, rectangles, polygons, etc. we'll be seeing how much we can. So mostly we'll try to finish draw commands today. So let's move on to the AutoCAD now. So now we'll be moving on to our software, AutoCAD. So let's start with our AutoCAD. What are the various tabs, what are the various features available for us. So over here we'll be having this, the version over here, what version AutoCAD we are using. Then the file name, which file name we are using. So this is the default, it will be drawing number 1. Then after that, this is our menu bar. This is also our this is the tab bar over here. So we are having this draw command, draw tab over here. Then we are having modify tab over here. Then we are having annotation tab over here. Then layer tab, block tab, properties, groups, serialize, clipboard, and view. Then we have insert. This is the another tab over here. We have various types of tabs over here. We'll be studying them later on. So when we start a new file, so for example, I don't save this one. I'll be starting a new file over here. Over here, file, new, and I'll be opening a new file, CAD file. So when I get the new file over here, this is the fresh file. So for your understanding purpose, so if we see over here, we have got this graph over here. So for first, we won't be using this graph or grid. So let's cancel this over here. So you keep in mind, I'll be teaching these later on. What are these various tabs or various highlighted commands over here. So let's keep this, keep that in mind. Keep these on, the things I have kept on. This is polar tracking and OSNAP. You have to keep on at anyhow. So why we have to keep them on, I'll be telling these things to you later on. So right now you can't understand why these are necessary. So now, since we have got this black area over here, so this area is called workspace, and this over here is called command line. As I have told you earlier, our earlier versions were command based software, so it was like the DOS system. So we had only this command system. This graphical interface was not that much advanced at the time. So we'll be using command line mostly, so that way you'll be understanding the CAD commands very well. So you won't be using these tabs, you won't be depending upon the tabs that much. Then we have this coordinate system over here. This is called UCS. If you see this command over here and this WCS over here, this UCS is called Universal Coordinate System. So if we go for 3D over here, so you can see the command system has changed from this X, Y, Z. So since we are working with 2D only, so I'll be using X and Y only. So after that, now what we will do is we'll be seeing this workspace is our, like, if we are drafting anything or any drawing. So if we are drawing or drafting any drawing, so first of all what we will be needing is we'll be needing a drawing table, and then we'll be needing a workspace, we'll be needing a drawing sheet. So first of all what we'll be doing is we'll be setting our up our, say for example, uh, a drawing sheet. Say for example, if you want to work in this area, would you know how much this area is? So to measure how much this area is, first of all what we'll be needing is units. If you want to measure this, so you have to measure this in meters, inches, foot, millimeters, kilometers, whatever the scale would be. So first of all what will be needing is we'll be needing the units. So to set up the units, we have the command units. We have the command units, or simply we can write un is the short form for the units command over here. Then we'll be getting this units window. Then for the length I can use anything. Decimal means, like, if you see decimal, this means we have to keep the metric system scale over here. If we are going for architectural, then we have to use feet system over here. If we are going for the engineering, so this is also for this feet system. And then fractional means 1 by 2, 1 by 4, or any length we can measure in fractions. So let's say for example scientific, we can use exponential system for that one. So I'll be using architectural, since architectural and engineering are almost same, so I'll be using architectural unit system. So that means I'll be working with feet and inches. So for the unit scale, I'll be using this lesser of these two, so that means I'll be using inches. So, lesser of the feet and inches, so I'll be using inches. Then for the angle, let's keep this in decimal degrees rather than degree radians, because that the conversion would be a little bit tedious later on. So I'll be using this decimal only. And then the precision, I'll be using 0.00 for this one, since I have got the limits, I have got the units for that one. So now let's set up the our drawing sheet. So to set up the drawing sheet, we need the command limits. Limits means the limits of our drawing sheet. This corner, this corner, this corner, and this corner limits. So to set up the limits, if you see when I have typed the limits command, so the limits for the it it's asking me to set up the lower left corner. I can set the lower left corner over here, but I want the lower left corner at the extreme point of this one. So 0 feet I'll be typing. So it's by default it's 0 feet, 0 inches. To make it sure, I'll be typing 0 feet, 0 feet in x direction, comma, and 0 feet in y direction. So now I have got this one locked at 0 feet and 0 feet in x direction, 0 feet in y direction. So by default the size of our drawing sheet has been kept as 35 feet in x direction and 24 feet in y direction, 24 feet and 9 inches rather. So to change this one, let's keep our page units, this upper right corner as, for example, I'll be keeping x as 150 feet, and I'll be keeping this y at upper right corner as, say for example, 100 feet. So now I have got this sheet size of this one, so I can cross check the limits whether I have got this drawing sheet equal. So the lower left corner I'll be keeping as it is 00. So now by default it's coming as 150 and 100. So I have got this size. It will be obviously much more, but it won't be less than, our drawing area won't be less than 150 and 100. So it will be much more, it will be obviously higher than this area, but it won't be lesser than this area. So now after we have got this unit set, we have got the limits set. So now let's go for a command. Let's go for the draw commands. So if you want to draw a line, so we'll be going for this line command. Line command is line command, or you can simply type L, the shortcut for the line command. So then we have to specify first point and then second point. Then since we are in continuity command, we can go for another line. So if you want to escape from this line command, we have to type escape, or we can go again in line command and then type line and then right click over here and then enter. Since we have got the lines over here, then this is this when we go for the line, we have got first point, second point and third point. Since, as I have told you earlier, to keep polar tracking on and snap on, so what does that mean? I have kept this on. Tapping escape, getting out of a command. So let's go for the line again. So if you want to join this corner and this corner, so if you see a green box is coming over here, green box and green box over here, so these are the end points of the line, and then there are also mid points of the line. So when I'm going near to this line, so this end point is catching me, so this end point is catching my cursor, so this is called snapping. So this, we have to keep this O snap on. So if I keep this O snap on, so if when I go close to this one, so this is not coming close to this one, so I have to keep this one on to catch this. So now I can join these two. So similarly when I was trying the line command, if you see, when I specified the first point, I was able to go for 45-degree angle. I was going for the 0-degree angle. I was going for this 45-degree angle, 90-degree angle, and then 135-degree angle. So to draw this line at some particular angle, a straight line, so what we need to do is we have to keep the polar tracking on. If I am not keeping the polar tracking on, so what will happen is when I am going for the command line and I am specifying the first point, I cannot draw the line straight. So it will be much more difficult to keep the angle 0 degree 0.00 degree. So when I am taking this polar tracking on, so 0 degree I am getting easy, I'm getting 45-degree easy, and I'm getting 90-degree easy. So if you want to get any other angle, like say for example 30-degree angle, so what I have to do is I can change this combination of angles over here. You can change this from 5, 10, 15, 20, whatever you want. Say for example, if I want 5, if I'm going for the lower scale 5-degree angle, when I'm going for straight, this is 0-degree angle, I'm going for 5-degree angle, I'm going for 10-degree angle, I'm going for 20-degree angle, 15-degree angle. I can change the angles over here. Even in tracking settings, I can keep the increment equal to 1 degree also. So let's keep this angle equal to 45 as it is by the default, so keeping it this one. So this one is for this line command. So for today we'll be finishing only line command, simple line command. So in next lecture we'll be going for this and the various other types of line commands. So hope you have got the lecture very well, and hope you do. If you have got you practice for these things at home, and if you got any queries or any questions, kindly text me, kindly call me. Thank you.